No, sir.
No, sir.
Is there any question
No,
from
sir.
your side? Okay.
Sir.
Then we may continue with the fundamental design considerations. You see, after discussing the factor of safety and all other things, I think we should also consider, probably in our last class, we have considered economics or cost of the product, right? And standardization,
Yes,
all
sir.
other things we discussed.
Yes, sir.
Yes, sir.
Okay, okay. So today we will start with another fundamental consideration as strength. So as you know, strength by definition, what is strength? It is the resistance against the failure of the component, failure of the material. Now already you know stress strain curve, and from there already you know the definition of strength. And you, as you know, for brittle material and ductile material, the strengths we considered in our design are different. For ductile material, we consider the yield strength of the material as the design parameter. For brittle material, it is basically the tensile strength. So when a load is applied to the component or to a member, so some stresses will be developed in the member, in the component. So we have to check whether that stress, developed stress, is less than or equal to the yield stress for ductile material or tensile stress or ultimate tensile stress for the brittle material. Now, depending on the loadings, the strength to be considered in the design are different. Say, for example, when you are considering static loading, at that time only we can say yes, for ductile material we should consider yield strength as a design strength. For brittle material, for under static loading or ultimate point stress. But when that load is not static, when the load is a dynamic, then this yield strength or based on yield strength or tensile strength, it may not be possible to design the component. We have to change that thing. Say, for example, you have one shaft. Say this is my shaft, and the shaft is rotating, and this is supported on, say, bearings, or say like this, not like this. Okay. Now what will happen? This shaft, when the shaft is transmitting power, say, the fibers will undergo tension and compression. Now, this phenomena is basically called the fatigue phenomena. So this shaft is not subject to static loading. The shaft is subject to fluctuating loading, or more specifically, it is basically fatigue loading. Now, when the shaft is subject to fatigue loading, using yield strength or tensile strength of material, we cannot design a component. Then we have to find another parameter or another strength parameter that is called endurance limit of the material.
স্যার
Or it is
রোটেশনের
also
জন্য
called, yes, 1 minute, fatigue limit. What will happen? Under this condition, these fibers will be under compression. The upper surfaces or upper fibers will be under compression. The lower one will be under tension. After half revolution, these fibers will come here and these fibers will come here. Now, these fibers, what will be here now, will be under compression, and these fibers, initially it was there, these fibers will be under tension. So periodically, the fibers will be subjected to tension and compression, and this will continue, right? So this phenomena is basically called fatigue phenomena. So this shaft or the shaft material will be subjected to fatigue loading. And then only using yield strength or tensile strength of material, we cannot design it. Then we have to go for endurance limit or fatigue limit of the material to make the design of this component, shaft component. So depending on the loadings, we have to consider the appropriate strength to make the design possible. My point is clear to you now?
Yes, sir.
Yes, sir.
Okay. Now the thing is, similar to these loadings, the materials may be subjected to different types of environments. The temperature may be different. In one class, we pointed that depending on the temperature, this material property, say for example, this is your stress strain curve of steel material, mild steel material. Now, this test is carried out at room temperature. If I increase the temperature, if I increase the temperature or decrease the temperature, we may not get similar type of or same stress strain curve. Your stress strain curve may differ. And when the stress strain curve is not same, there is a change, there is a difference in the stress strain curve, then this yield point or tensile strength of material, this may also change. So depending on the temperature also, we have to consider that thing, and we have to understand that with the temperature, with the environment, we need to consider a different property so that successfully we can make the design of the component. Say for example, we have one component. Say there is one shaft with some attachments, but this shaft is here for say 1 year or say 2 years, 3 years, 5 years, 10 years. Then what will happen? If there is nothing, then also the component will experience some amount of stress due to the self weight. Now this type of stress is continuous stress. All the time it is there, and it is for a longer time. And then this component may experience continuous deformation under load, and this phenomena is called creep phenomena. And when there is another added parameter to this as temperature, then this creep phenomena will be more active, and we have to consider the design procedure under creep to make the design of this component. So we will define these parameters: endurance limit, fatigue limit, design under creep, all other things. But at this point, you should at least know, yes, depending on the environment, depending on the loadings, we have to think which strength should be considered in our design. So there are different things: load, maybe environment, maybe material. Depending on, we have to consider the appropriate strength, and strength is basically one fundamental design consideration in any design. Is there any question from your side?
No, sir.
The next parameter we may it's called reliability of the material or reliability of the design. What is reliability? What is reliability by definition? You know, reliability is basically one statistical measure. So this is statistically, we can say what is the probability that a material, one component will not fail in use. If I say the reliability of the component is 99%, so we can say yes, out of 100 products, 99 products will survive for its specified task, specified job. It will perform the specific task. So that is the probability, 99% probability that it will do. So as you understand that if I try to increase the reliability of the product, it is directly related to the cost of the product also. If I try to increase the reliability, yes, if I try to make one design that the design will not fail with 99.99%, then we have to take a higher factor of safety. We have to take a material which can perform well in that situation, in that environment. Now, when we are trying to increase that thing, when we are trying to increase, say, for example, factor of safety, the dimension of the product will increase. As a result, the final cost of the product will also increase. So we have to do some optimization of this. What should be the accepted level of reliability so that that product will be competitive enough in the market. At the same time, the product will perform well up to its specified life. You will find that for different products, there is one warranty period. Say warranty period of 6 months, 1 year, 2 years, like this. Now buyer, if the all other specifications are same or identical, then always the buyer will try to purchase that component which will give you better or more warranty period. So warranty is basically the liability to the manufacturer. When there will be a damage or when there will be failure of the product within that warranty period, the manufacturer will be liable to pay or liable to compensate that thing. And if the reliability of the product is say 50%, so there is a chance that 50% of the product fail within the specified limit, then the manufacturer has to pay a damage to those products, and that is the liability of the company also. So in the company, they try to optimize the things, and suitably, they want to make the reliability of the product so that it is reliable. At the same time, the cost of the product can be minimized or optimized in a better way. So reliability is also another design aspect or fundamental design considerations that should be used at the design stage. Now another thing, there is aesthetic features of the component. What is aesthetic? Aesthetic basically by meaning is beauty of the product or styling of the product. Now how the aesthetics may influence the design? Suppose you are trying to purchase one car, 4-wheeler. If all of the specification, all your needs are satisfied with say 2 models, I do not want to mention the model name here. Say for example, there is X1 model and X2 model. Now, specification wise, these 2 models are okay. Price wise, these two models are accepted to you. Definitely, one parameter should be there that the beauty of the product, the beauty of the car or styling of the car is appealing one or attractive one, or looking of the car is attractive one, and you will go for that thing. If all other features are same, say for example, there are many points, there are many uh, parameters, but if I say yes, all the parameters are accepted to you, then definitely you will see the beauty of the product. So always appearance of the product is one point or one parameter in design. You have to make the parameter, you have to make the product in a way that the customer will get attraction to that. You are making one building, so you have to make some design that it looks better. So always the aesthetics features of the design is one fundamental design consideration you have to consider at the design stage. So appearance one important parameter in the design. Basically in industrial, in classroom design, we cannot do with this thing. But in industries, always they will look after these aesthetic features of the material, aesthetic features of the component, definitely. So in the presentation also, there are different points. I am not going point by point there, but I think you understand what is aesthetics. Also, aesthetics is related to design. And also you see, when you are making good surface finish of the product, very smooth surface of the product, then the looks of that product will be better. If you consider one shape, and shape may be related to your, say, design parameters, shape is another appealing parameter where you can regulate the shape considering the design, and you can make one product which will be more attractive. So there are different parameters. The parameters are there in the presentation. Please go through that. But basically, aesthetic is basically the beauty of the product or styling of the product. Is there any question from this?
No, sir.
Okay.
No,
Another
sir.
point. Yes. Okay, good. Another point here is ergonomic features of the component. Ergonomic features or ergonomic considerations. Now, one thing is aesthetic or beauty of the product. Another thing is ergonomic features. That is basically how easily you can use the product. What is the comfort level when you are using the product? That is called ergonomic features of the product. So that is basically a communication between the user and the machine. You have one, say, micro oven. If there are many buttons, many things, it may not be useful to you. You have purchased one product. How easily you can operate that thing. So it should be user friendly. We call it user friendly. So ergonomic basically the relation between the man or the user with the machine. So ergonomic features should also be considered in the design. This point is clear to you?
Yes.
Yes, sir.
Yes, sir.
Okay. Now we'll discuss another thing. So what are the fundamental design considerations we have discussed? Sorry. Fundamental design considerations. Probably I started with safety, use of standards and codes. Number 3, economics or cost. Number 4, strength. Number 5, oh, what is the number 5? I forgot.
Aesthetic appearance. Sir, aesthetic.
Aesthetic, yes. Or reliability, okay. Aesthetic, ergonomics, reliability, it may be the life of the component, life of the design. Already we discussed some part of the material. Again, we'll discuss that thing. Then also, we have to consider some manufacturing aspects. Manufacturing aspects in the design. Another thing is called environment. We call it friendliness, friendliness. Basically, nowadays we are going for green design, where carbon emission is can be restricted. Another thing is maybe recycling of the product. And whether you are making a design which can be updated later on. In your mobile phone also you have noticed that initially suppose one Android version was there, and sometimes after some time say they are updating the operating system, Android version 1 to another one like this, whether that upgradability is there or not in your design. So this way you will find different parameters or different design consideration. Those should be considered in your design stage. Okay. Now, yes, I will discuss that thing. And to start that topic, basically, I am starting another point. Understand this material and manufacturing aspects, all the things I will discuss here. Now, when we are making one design, you know, I'm making one design, say, but we engineers will make out of the things, out of the material, right? So design is not one standalone process. There are materials and processes which are connected to this design. Why are I making this statement? Because when we are making one design, say, we have to use one material. And when we are considering one material, that material should support, or that material should survive the applied load. And the material should perform the specified work without failure. And when we are making the things out of a material, it has to be given a shape. And for this, we require one process. Also, when we are considering one process, depending on the process, the mechanical properties, many design considerations may be affected or may be influenced by the selected process. So this design is not a standalone one, but the design is basically one interdisciplinary subject, as I mentioned earlier. Also here, when we are trying to make the design, at the same time, we have to consider the material, we have to consider the process. Keeping all these things, we have to make the design. So when we are coming to these materials, what are the materials? So initially or mainly we can classify as metals and non-metals. Under metal, we can make ferrous and non-ferrous, right? You all know what is ferrous material, what is non-ferrous material, what is metal, what is non-metal. Now coming to processes, mainly we can classify processes into three. One is called casting process. Probably you have studied this thing.
Yes, sir, we have started.
Okay, casting process. One is deformation process. Third one is material removal process. Or machining process. So in casting process, as you know, there should be one pattern, and using that pattern, we will make the cavity in the sand. Though there are some sophisticated instruments also. So using sand, you will make this thing generally, and after making the cavity, you will pour the molten metal, and after solidifying, you will get the product. In deformation process, say for example, we have forging, rolling operation, extrusion, etc. Okay, so here generally we apply force to deform the material, and these materials should have a large plastic deformation. That means before the fracture, the material should deform a large plastic deformation, because here when you are trying to deform the material, that deformation should be plastic in nature, not in elastic, because if it is elastic in nature, then after removing the load, it will regain its original shape and size. So here for forging operation, rolling operation, extrusion operations, for all the operations, plastic property is very much important. Also for material removal processes, as you know, it may be turning, milling, grinding, shaping operation, etc. Understand? Now, when we'll try to select the material, when we try to select the processes, what are the parameters we should consider? First of all, you see, when we are trying to consider the material should be largely available. If the material is not largely available, then you may face some problem at the design stage. So the material should be available. Secondly, the properties of the material should be suitable for that particular application, or properties may come first also. Properties, then you may say yes, available. So first we should tell yes, what are the properties we require. And depending on those properties, we have to select a suitable material so that the design can perform its specified task. Secondly, the material should be available. But the main parameter here is the cost. So when we are trying to select one material, we should consider whether that material has the specified properties to perform that specified task, whether the material is available, whether it is cost effective or not. Then only you may say, yes, this material, this plain carbon steel of this grade, or say cast iron, or say brass, or say bronze, these materials are okay. We can use that material for this. But at the same time, when we are trying to select the material, at the same time, I have to think by which process I will make that thing, make the component. You are taking steel material, stainless steel. And if you specify that we have to do this product using casting operation, then you may get some difficulty there. Why? Because generally for casting, we use cast iron of different grades. When you are trying to use the steel material there, then it is very tough, it is very hard to make the casting of that. It is possible, but the failure chances are great or failure chances are high when you are making the casting out of steel material. Also, you may think about say forging, rolling, extrusion, or say some machining operations, but you have to think or you have to know what should be the properties or design parameters after the product development. Say for example, we are doing say casting operation and forging operation, or say rolling operation. Now you see, in casting operation, when you do the casting, there are some defects. There may be blowholes or other types of defects. And when it is there, the strength of the material will be low. But in deformation process, in forging or in rolling operations, since the material will undergo deformation process or plastic deformation, we may expect a reasonable amount of strength in the material compared to casting process. In forging or rolling, the strength values will be much higher. Also for say surface finish, surface quality of the product, we define this surface quality as a surface roughness. Later on we will discuss what is surface roughness, statistically how we can calculate the surface roughness of a surface. But the thing is, in different applications, there are some specified levels of surface roughness values. When you have to minimize the friction and wear of the component, for those applications, always we try to make the smooth surface. But in case of say brake, clutch, in case of brake, if the surface is very smooth, then slipping of the surfaces may be there. So we do not prefer that thing. So depending on the applications, we need to select the proper surface finish or surface roughness of the material. But depending on the processes, the surface quality may differ. Also for say material removing processes or machining processes, if I try to make one shaft using say turning or milling or say grinding, the surface qualities of these machining processes will be different. At the design stage, as the designer, has the information, what is the function of the component, what is the loading amount or the load to be subjected to that component or to the machine. He has to understand that using this specified using the specific material, using the specific process, we have to make the design. Then only you can make one successful design. Otherwise, it is very difficult for us, because depending on the material, depending on the processes, some parameters, some properties may differ, some functions or design considerations may be different, and at the design stage we have to think which material and by which process we have to make the component. This point is clear to you?
Yes, sir.
Yes, sir.
So the processes, yes, good. So at the design stage, we have to think which process should be considered. And say, for example, I am preparing casting operation. So as a designer, I should know, after making the component using casting operation or during the casting operation, which parameters or what are the things should be considered. That is basically called manufacturing aspects in design. So at the design stage, we have to specify. We have to mention that thing in the design. Yes, you have to do the casting this way, so that I can get the specified properties in the material. We can say, yes, for the casting operation, we have to make the casting in such a way that the machining of the component can be minimized. Why? Because when we are trying to do the machining operation, extra amount we have to pay, the cost of product will increase. Not only that, you know from your, I think, material science class, depending on the cooling rate, the material properties may differ. Have you studied material science?
Yes, sir.
Yes, sir.
Okay, so I think you know TTT diagram,
Yes, sir.
Yes, sir.
temperature, time, and transformation diagram. So from here, depending on the cooling rate and the time, you will get different grain structure, and depending on the grain structure, the properties in the material will be different. And in the casting also, in the outer surfaces, cooling rate will be higher compared to the inner surfaces. Suppose you have one casting of, say, thickness, say 30 millimeter. So in the inner areas, the cooling rate will be low compared to the outer surfaces. And when the cooling rate is faster in the outer surfaces, the strength will be higher in the outer surfaces compared to the inner one. And now when you are trying to remove the material of this casted material, then basically you are removing the stronger part of the material, stronger part of the component. So for casting operation, always we try to minimize the machining operation to make the final product. Understand? So this way, we have to consider these parameters at the design stage. That is called manufacturing aspects in design. Also, for the materials, we have to know what are the properties we should consider at the design stage. What is the function of the component? At the same time, what are the material properties we require for that purpose? So now, if this point is clear to you, we may start with the material properties. Is there any question from your side?
No, sir.
Now, we may start with the material property. So what is the first material property we have? The first material property we have the strength. What is strength? It is the ability of the material. What is the strength? Any idea? We have already discussed this thing.
Failure. Sir, resistance to failure. Sir.
Resistance to failure. And it is yielding for ductile material, and it is tensile strength
Brittle material.
for
Brittle
brittle material. Yes. Now that is called strength. So by definition, we can write like this: strength is the ability of the material to sustain externally applied load without failure, right? Sorry. So it is yielding for ductile material, and for brittle material is your tensile strength or ultimate point stress. Number 2, say elasticity. So we are getting this type of material property from stress strain curve. So how we get the stress strain curve? We have to take one standard specimen and we have to apply load, tensile load to the specimen using one machine. That machine is called universal testing machine. So using UTM, universal testing machine, we try to do the testing taking one standard procedure. It may be ASTM standard or any other standard. Taking that standard, we will conduct the test by applying the tensile load, taking a standard specimen, and we will try to record the data, and from there we will try to draw the stress strain curve for the material. And from there, from the stress strain curve, we may get these different types of material properties like strength, like elasticity. That is, elasticity is basically the ability of the material to regain its original shape and size. Number 3, say plasticity. So it is the ability of the material to retain, not regain, to retain the deformation on a permanent basis. So it is the ability of the material to retain the deformation on permanent basis. It may be stiffness. What is the stiffness? It is called ability of the material to resist the externally applied load resist the deformation under the action of externally applied load. So the modulus of elasticity, as you know, modulus of elasticity is the measure of stiffness. Now, what is the difference between these two? And anyone please tell me? If you compare the strength and stiffness, What is the difference? It's called stiffness, or also it is called rigidity. When we can use the strength as a design parameter, or also when we can do the stiffness. Say for example, we have one shaft. We are taking the shaft here only. And the shaft is supported on bearings. It is rotating. Now what may happen that we can design the shaft based on strength. Also, what we can do, or what may be the failure, due to the weight of the shaft itself, or due to the weight of the attachments. There may be say shaft coupling, there may be say pulley, gears, all other machine elements may be connected to the shaft. Now due to the weight of the attachments, your shaft may be deformed like this, say. Understand? Shaft may be deformed like this. I should use a different color. Anyway, I have already made it. Do you understand the figure?
Yes, sir. বুঝতে পারছি মানে একটা bend হয়ে যাচ্ছে
Yes, sir.
basically.
Yes. Due to the self weight, there should be some bending of the component. So that is basically the deflection of the thing, deflection of the component, right? Now this deflection or deformation is due to the loads. Now there should be some permissible level of deformation. Beyond that, if your deformation is there in the machine element, we'll call the component is failed due to stiffness or rigidity. It is true, when we are applying the torque, you know theta is equal to I think you know this equation.
Yes, sir.
Yes, sir.
Theta, TL by GJ. So what is theta?
So angle of
Angle
deflection.
of deflection.
Yes, angle of deflection. So we can make the design in a way where we'll consider the angle of deflection. Because here you see, if I specify that your angle of deflection should be say 0.25 radian per meter length of the shaft. For example, say. So when we know this value, so this value is basically theta per meter length of the, it may be in radian, it may be in degree. So as you wish, we have to convert the value. So in this equation, if we try to use that thing, it should be in radian. So theta is TL by GJ, and G is the material property, T the applied torque, L from the geometry you will get the value L, and J where we may calculate polar moment of inertia in terms of the dimension of the component, dimension of the member. Now from here also you can calculate the dimension or diameter of the component. So that's basically called stiffness of the component. But here we are not considering the strength of the component. If I try to design the shaft based on strength, then suppose I have only torque amount. So you know 16T by pi d cube, that should be the equation. So if I use this equation to calculate the shaft, then basically we are following the design based on strength. But when we are using the lateral deflection or angular deflection of the component, and we are trying to keep that angular or lateral deflection within a limit, and we are trying to get or trying to find the dimension of the component, that design procedure will be based on stiffness or rigidity. So in our class also, we'll try to make the design of component based on strength, based on stiffness or rigidity, also based on a code, as I mentioned earlier. This point is clear to you? Is there any
স্যার
question?
এখানে স্ট্রেংথটা তাহলে মানে খুব বেশি এফেক্ট করবে না মানে
No, the procedures are different. Your procedures are different.
আচ্ছা
In
মানে
this
স্যার এখানে
equation, you have to find the material property, say yield point shear strength. And from there, you have to find this tau value, and from there, you may calculate it. So this is based on strength. Understand? But for this one, we know for the proper functioning of the component, for proper functioning of the machine element, what should be the maximum deflection you can permit. So as a designer, the designer should know what is the maximum permissible deflection of the component for the proper functioning of the component. Because you see, this shaft is supported on bearings. If the deflections are more, the bearing will fail. You cannot go to any value. So you have to restrict the deflection. And when you are trying to restrict the deflection, you have to choose a proper material so that you can restrict the deflection within that specified limit. Similar to the deflection, angular deflection may be there. So depending on the problem, depending on the need, you have to think in which way I have to make the design of the component. So there are different methods, different ways you can find the dimension. So from the problem statement, you have to understand, yes, this way I should go. Because when you will do this shaft design in the industries, then all the things should be considered. The shaft should sustain the load. At the same time, the deflection of the shaft should not be too high. When due to the deflection, your proper function of the component will be hampered, or due to the angular deflection of the component, the proper functioning is hampered. So you have to design the components using the correct procedure.
Okay,
that point is clear to you. Yes, because here some amount of torsional moment you are applying, the fibers will try to rotate. When there is one fixed end, you can notice that thing in a better way. But when you are applying some amount of torsional moment, you are twisted, there is a twisting moment, then some amount of angular deflection will also be there. So in our next class, we may continue from this. Please go through the presentation. From next day, we'll start other mechanical properties. Also, we'll try to discuss the manufacturing aspects and design, and we'll try to complete the presentation number 1.
Sir. Okay, sir.
স্যার
Yes.
স্যার বলছি এই যে দুটো ইকুয়েশন স্যার একটা ইকুয়েশন থেকেই তো আসে, এই টাউ বাই আর ইজ ইকাল টু জি থিটা বাই এল ইজ ইকাল টু টি বাই জে। এই স্যার এইখানে থিটা ইজ ইকাল টু টি এল বাই জি জে আর টাউ ইজ ইকাল টু 16 টি বাই পাই ডি কিউব, দুটো তো স্যার একটা ইকুয়েশন থেকে আসে। তাহলে কি ডায়ামিটারটা স্যার আলাদা আলাদা হবে ক্যালকুলেট করলে দু ক্ষেত্রে?
If you consider these two different equations, your dimensions will be different. When we will discuss the design procedure of shaft, at that time we will consider these two methods, not two, three methods to make the design of shaft. One should be based on strength, one should be based on rigidity, one should be based on code. Because here you see in the shaft, sometimes in addition to torque, there should be other loadings also. It may be bending loading or bending moment, maybe axial loading. So you have to combine those loadings to make the design. Also, you have sometimes we are considering the lateral or angular rigidity. Also, we will go for ASME code to make the design. Please wait for some times. Definitely we will demonstrate the problems here in the classroom only.
ওকে স্যার।
স্যার তাহলে এই স্ট্রেনটা তো হচ্ছে আপনার ফিজিক্যাল ফেলিওর হচ্ছে আর ওই ইয়েটা আপনার ফাংশনাল ফেলিওর হচ্ছে স্টিফনেসটা।
Functional failure.
Stiffness, you can see the deflection. Basically, when you are applying or you are using one machine for this type of machine shape, so there should be some permissible level of your deflection. In your engineering mechanics, you know how to calculate the deflection when the loadings are known to you or when the values are known to you.
Yes,
And
sir.
you need to calculate the deflection value, and then only you can say whether your design is safe enough considering the lateral rigidity or lateral deflection. Okay, so definitely you are getting the flavor of design right now. Definitely we will design the component under these situations. Okay, so have you recorded the class? Anyone? Have you recorded the class?
Yes, sir. Yes, sir.
Okay, okay. So I think if that option is not here, the recording option is not available in Google Meet. No, now also it is not there. Then we have to change the platform. So wait for 1 or 2 days. Then again I will contact you. So if possible, I think we have to shift to another platform, like say Zoom. So I have Zoom here also. So if you can arrange that thing, so using Zoom platform also, you can take the class.
ওকে স্যার।
Yes, sir.
Okay.
থ্যাংক ইউ
Okay. So next class will be on I think Tuesday.
Yes, sir. Tuesday from 1
Yes.
p.m.
Tuesday. Okay. 1 to 2. Okay. I will inform you whether I will be available from 1 to 2. Then I will post the link in Google Classroom.
Okay,
Okay.
sir.
So thank you very
sir.
much. Thank you very much.
Thank you,
We'll meet
sir.
again on
Thank you, sir.
Okay. Thank you.
Thank you,
Thank
sir.
you.